All right, in section 6.5, we are going to look at solving square root equations. We've been looking at what their graphs look like. We've been looking at how to write them not necessarily with a square root symbol, but with a rational exponent. So we're going to start in this section looking at how do we solve equations that have those symbols in them. Okay, so it might be a rational exponent, it might be a radical symbol. It says a radical equation is an equation that has a variable in a radicand or a variable with a rational exponent. Okay, so again, there's a variable inside your square root symbol, or you have x to some fraction power. Okay. A square root equation is an equation that has a radical of index 2. Solving a square root equation may require that you square each side. If you're trying to get rid of a square root symbol, we can get rid of it by squaring both sides. However, this introduces extraneous solutions. Have you heard that term before? Okay, those are the solutions that are extra, right? They don't actually work. To solve a radical equation, we have to isolate the radical on one side and then raise each side to a power based on the index. Okay. Our first one. Notice that we have some pieces that are not inside the square root. We want to get anything that's not inside the square root to the other side. Okay, so my first step here would be to subtract 3. And we end up with the square root of 2x minus 3 now equaling 5. Okay. To get rid of the square root symbol, we're going to square both sides. On the left side, the square and the square root cancel each other out, so we just end up with the 2x minus 3. On the right side, we get 25. All right, and now we just have a regular linear equation to solve. Okay, so we're going to add the 3 to the other side and then divide. Because of those extraneous solutions that are possible, we always want to check our answer. We check it by plugging it back into the original equation wherever there's an x. So my check would look like this. Okay, inside 2 times 14 is 28. 28 minus 3 is 25. Square root of 25 is 5. So, does it work? Yes. Okay. All right, our next one, what would we do first? We need to move that negative 5 out of there. Okay, we have to isolate the square root symbol. So let's add 5 to the other side. Okay, what's our next step? Square both sides. All right, once again, 5 squared is going to give us a 25. On the left side, our square and square root cancel each other out. What do we do next? Subtract the 1 over, and then divide out our 4. Okay? All right. I'm going to pause the recording. You guys go ahead and check to see if that works. All right, checking. We have the square root of 4 times 6 plus 1 minus 5 equals 0. We've got 24 plus 1. We've got the square root of 25 minus 5 equals 0. And it does work. Okay? All right. So in the 2 examples that we just looked at, we had a single square root to deal with. Okay? We're going to look at some now that have that rational exponent instead. It says to solve equations that have the form something like x to the m over n power equaling some constant. We have to raise each side of the equation to the reciprocal power. Okay? I want you to think about that for a second. If I have something to, say, a 4/5 power, that means whatever I have, I'll just put an x here. X is being raised to a fourth power, and then we're taking its fifth root, correct? Well, we want to reverse those two things. To undo a fourth power, I need to do a fourth root, which means I would have to have a 4 in the bottom of my fraction. To undo a fifth root, I need to raise it to a fifth power. Okay? So we can undo this by using a reciprocal power. Does that make sense? Okay. So looking at our example, oh, I should talk about this here. It says, if either m or n is even, then we have to think about the absolute value. Okay? Another way of saying that is we need to include that plus minus. We have those options. If we are trying to square root something, we put a plus minus in front, right? Okay. So for our example, notice that this 3 outside here is not being raised to the power. So we need to move that out of the way first. We're going to have x plus 1 to the 2/3 power equaling 4. If we divide that over. So we have a 2/3 power. That means we are taking x plus 1 and we are squaring it, right? We're raising it to a second power, and then we are going to cube root it. Okay? To undo that, I need to use the reciprocal power. So I am going to raise both sides of my equation to a reciprocal power, in this case a 3/2. Okay? Now, analyze what we are doing here. That 2 on the bottom means that I am square rooting that 4, correct? And anytime we square root, we have to put a plus and minus in there. Okay? All right. On the left side, a 2/3 power and a 3/2 power are going to cancel each other out. We end up just with x plus 1. On the other side, we are going to get the square root of 4. Okay, we're going to take that square root of 4. Yes? Which gives us what? Plus or minus 2. Okay. And then we're going to cube it. Well, what happens when we cube a 2? We get 8. When we cube a -2, we get -8. So we end up with x plus 1 equaling plus minus 8. Okay. Now, up here we wrote that as, we would have said it's the absolute value of 8, but again, that could be positive or negative, okay, inside there. So instead of having to worry about putting absolute values around here, we just put the plus minus with the 8. Does that make sense? Okay. All right, to solve this, we do have two equations. One where we have x plus 1 equaling 8, one where we have x plus 1 equaling -8. Subtracting 1 over, we end up with a 7 or a -9. All right, we need to check both of those. So let's check the 7. Again, you have to put it in the initial equation. All right, let's check the first one. 7 plus 1 is 8. 8 to the 2/3 power. We have to cube root it, which gets us 2, and then we have to square it. So we have 4. So is 3 times 4 equal to 12? Okay. On this side, -9 plus 1 is -8. Square rooting it, sorry, cube rooting it. Cube root of -8 is -2. -2 squared is still 4. Okay, so both of them work. We would list both as answers. All right, take a look at the next one. I'm going to pause the recording. I want you guys to talk at your table. What would the first couple steps be for solving this? All right, what did you do first? Okay, subtracted the 1. Again, we're trying to isolate that part, correct? So subtracting the 1. Then what? Divide by 3. So we have the 5th root of this quantity to the 3rd power equaling 8. Okay, now we can leave it in its radical form like it is and undo it, or we can think of it with that rational exponent. If I am taking x plus 1 and cubing it, and then I'm going to take its 5th root, I could write that as x plus 1 to the 3/5 power, correct? Do I have to worry about a plus minus on this one? No, because my numbers here are both odd. Okay? How do I undo a 3/5 power? And be careful saying times it by. You're not timesing it by 5/3. You are raising it to a 5/3 power. Okay? The left side cleans up to being just x plus 1. On the right side, we have to take the cube root of 8, which is 2, and 2 to the 5th power. Okay. Subtracting the 1, we end up with x being 31. Okay? Again, checking it. All right. 31 plus 1 is 32. I can do the 5th root first, right? The 5th root of 32 is 2. 2 cubed is 8. I forgot what? Oh, I did. There's a 3 there. All right, there we go. So 2 cubed is 8. 3 times the 2 cubed, 3 times 8 is 24, plus the 1 gets us 25. Yes? All right. Go ahead and try this one on your own. Only check in with the people at your table when you are finished. All right, first step, we would have to divide out the 2. We undo a 2/3 power by raising it to a 3/2. Okay, and again, instead of using the absolute value bars, we can just say then that we're going to have 2 options, right? A positive and a negative. Again, it's because of this here. We are square rooting. We need that plus minus. So the square root of 4 is 2. 2 cubed is 8. We're going to end up with positive and negative 8. Yes? Subtracting 3 over. So the 8 minus 3 gets us 5. And the negative 8 minus 3 gets us negative 11. Okay? Did you check them? Yes. Do they both work? Okay. All right, last question. It says, for meteor crater in Arizona, the formula D equals 2 times the cube root of the volume divided by 3/10 relates the diameter D of the rim in meters to the volume in cubic meters. What is the volume of this crater? Now, what does it show us in the picture? It's giving me the diameter. What is the diameter? 1.2 kilometers. What does it have to be in? Meters. Okay, so 1.2 kilometers is the same as how many meters? 1 kilometer is 1,000 meters. Yes? So this would be 1,200 meters. Okay. Now, there's 2 ways we can do this. They are asking me to figure out the volume, right? given the diameter. I can dump that number in right away for diameter and solve for V. Or I could rearrange my formula so that it is solved for V first before I dump it in. Okay? Either way should get you to the same answer. What would you think to do? Would you guys dump it in right away? Or would you rearrange the formula? Rearrange the formula. Okay. If we have D equals 2 times the cube root of V divided by 0.3, how do we undo that to get V by itself? What would we need to do? Just like we were solving before, what would we have to do? Divide out the 2, okay? So we have D divided by 2 equals the cube root of that. Now what? How do we undo a cube root? What? Bring it to the third power. Okay, so we have to take both sides to a third power. We are going to have D divided by 2 to the third power equaling V divided by 0.3, 3/10. How do we get rid of the 3/10? Multiply it to the other side. So we have 3/10 times D divided by 2 cubed equals V. Okay, now we can dump in our 1200 for our diameter. Okay, so we're going to have 0.3 times 1200 divided by 2 to the third power. 1200 divided by 2 is 600. Take 600 and cube it, and then multiply by 0.3. What do we get? Anybody? It's a big number. What do we got? All right, I'm looking at this calculator. It has this. Yes? 64,800,000? Okay. What units would we tack on to that? Yes. Our diameter was in meters, so volume would be meters cubed. Okay, now again, did you have to go that route? No. We could have dumped this in right away into our original formula and then solved for V. We still would have had the same steps. Okay? All right, so for homework today, you are doing page 395, 9 to 25 odd, 73, and 75 to 96.